Okay, so what is a possible solution to the system of equations? So the key here is that it is an equation and not an inequality. So when it's an equation, there's no shading. So you're looking for where do they intersect. So it looks like it intersects. So we're looking at ordered pairs. So there's 1, 2, 3 and a little bit. So about 3, negative 3.5. And then we go up. It's not quite to 2, so we're going to say about 1.8. So this is, do not confuse this with slope. Solve the system without graphing. So I'm looking at this, and I can either use elimination or substitution. Okay. First of all, it's going to be a good one for substitution because, not substitution, but for elimination because everything is already lined up. These are already, the coefficients of the x's are already opposites. So I'm going to go ahead and make this a big addition problem because they are opposites. So that eliminates the x's. Negative 2y plus 8y gives me 6y equals, add these up, I get a negative 36. Divide both sides by 6 and get y to equal a negative 6. So I have half of my ordered pair. I'm going to go back and I'm going to plug this value into the bottom one because there's fewer negatives. So I have 4x plus 8 times the y that I just found equals negative 24. 4x minus 48 equals negative 24. Add 48 to both sides and have 4x equals 24. Divide both sides by 4 and have x to equal 6. So my final answer is 6 comma negative 6. Remember, we can verify that by checking it, by plugging this back into both of the equations. Solve the system without graphing. So again, I have a choice of elimination or substitution. This one could be used for substitution because I have x by itself, or not x by itself, but x has a coefficient of 1, y's have coefficients of 1 or negative 1, so substitution would work. I could also be solving this by elimination because again these are already coefficients are opposites of negative 1 and 1. Because I did this one by elimination, I'm going to go ahead and do this one by substitution just so you can see it again. So I'm going to solve for x. So I have x equals 11 plus y. This goes into the other equation. So 2 times the 11 plus y equals 19. Distribute. So 22 plus 2y plus y equals 19. Combine like terms. So 22 plus 3y equals 19. Subtract 22 on both sides and have 3y equals negative 3. Therefore, y would equal a negative 1. So all of that work for half of it. I'm going to go back to the original. So I have x minus y equals 11. I'm going to substitute that in. Be careful with this one because it's x minus my y, which is a negative 1, equals 11. Minus a negative is plus a positive. Subtract 1 on both sides and get x to equal 10. So my ordered pair is the ordered pair of 10, negative 1. Okay, I have another system here. I'm running out of room, so I'm going to bring that up to the top up here. So I have 2x plus 8y equals 6, and negative x minus 4y equals negative 3. So again, this one is number 13 that I'm doing clear up here. So number 13, you confuse this if you're watching the video. So on number 13, this one also you could use this by, or solve this by substitution because x does have a coefficient of negative 1. I could also do this by elimination, which is what I'm going to do. So I have 2x and I have a negative 1x. So these both have, I can get negative 1 to be a negative 2 by multiplying every term by 2. So I didn't do anything to the first one. And then my second one is going to be negative 2x minus 8y equals a negative 6. Okay, so something weird just happened. Opposites. So I end up with 0 plus 0 equals 0. So I lost my variables. It's a true statement. So this means my solution would be infinitely many solutions. If I would have lost the variable and this would have been a not true statement, so like 3 equals 4, then you would have had no solutions. And then I already, how many solutions does this system have? And the answer is none. True or false? If two equations have the same slope, the system has exactly one solution. So I'm going to do like some quick sketches of these. So for A, if two equations have the same slope, that means the lines are going to be parallel, which means they have no solution. So this is false. If two equations have the same slope and the same y-intercept, so that's going to be up here, same slope and the same y-intercept, means you're going to have one line on top of the other. So the system has no solutions. Nope, not no solutions. It would be infinitely many solutions. So that one is also false. If two equations have different slopes and then the system has exactly one solution. So different slopes. That means they're going to intersect. So if I have a slope going this way or a line with a slope going that way, and I have another line going that way, they're going to intersect at one point eventually. So it has one solution. So this is true. D, if two equations have the same slope and different y-intercepts, then the system has no solution. So I'm going to sketch it down here. Same slope and different y-intercepts. So there's that line, same slope, different y-intercepts. So we're looking at these as different y-intercepts, has no solution. And that is true. They will never intersect, so they have nothing in common. If two equations have the same slope and different y-intercepts, the system has infinitely many solutions. Well, we just said that this situation has no solutions, so that means this is false. And finally, number 15 on this page, you are running a concession stand at a basketball game. You are selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. How many hot dogs were sold and how many sodas were sold? So you are writing a system. So the first thing I'm going to deal with is cost, and I have to define my variables. So I'm going to have H equals the number of hot dogs, and I'm going to have S equals the number of sodas. So if we're dealing with cost, so $1.50 times my hot dog plus 50 cents per every soda is going to equal a total of $78.50. Need another one. We're dealing with the numbers. So I know that the number of hot dogs plus the number of sodas has to equal 87. So this one has some large numbers in it, so I could substitute because I have coefficients of 1 for H and the S. I could also multiply everything through and shorten this one up. I'm just going to use substitution here. So I'm going to say that H equals 87 minus S. And I'm going to substitute this into that one. So I have $1.50 times 87 minus S plus 50 cents times S equals 78.50. So this one's not going to be a very pretty one to deal with. So I have $1.50 times the 87 gives me 130.5 minus 1.5S plus 0.5S equals 78.50. Combine some like terms. I have 130.5, so I have a negative 1.5 plus 0.5 gives me a negative 1, so negative 1S equals 78.50. I'm going to subtract 130.5 on both sides. I'm going to bring this up here. So I have negative 1S equals 78.5 minus 130.5 gives me negative 52. Divide both sides by a negative 1, so S equals 52. So that means that there are 52 sodas. If I go back to my system, I know that there was a total of 87 items. Well, there's 52 sodas, so I'm going to do 87 minus my 52 and get 35. So that means there are 35 hot dogs. And if I check it, plugging in the 52, or excuse me, the 35 for the hot dogs, 52 for the sodas, that total should end up being $78.50. So that concludes that page.